Look at section 7.7. Solving radical equations. A radical equation looks similar to this. Or something of that nature. That's the simplest one. Okay. If I'm going to solve a radical equation, the first step is to isolate the radical by itself on one side of the equal sign. So if I look at this particular equation, the whole 2x plus 1 is a radical. Would you agree? Is it by itself on one side of the equal sign? Okay, so that first step is done. Second step, to get rid of the radical so that I can try and work with x, if its index is a 2, which in this case it is, I need to square both sides. Which means in this particular equation, I have 2x plus 1 equals 0. I need to square this side and square this side, because what you do to one side of the equation, you do to the other. Why would I square it? By squaring it, don't I get rid of the radical?
Yeah. Wait, if it's not, if the 2 is not the index, then what do we do?
Well, if it happens to be like a cubed or a fourth or a fifth, then you have to take it to that many powers. So if this would have been a 3, then this would have been a 3. And this would have been a 3. Does that make sense? Okay. So whatever the index is, that's what you have to do to both sides by putting it to a power. Well, we should know by now that if I take a radical, like I had the square root of x, and I squared it, or if I had like the square root of 2 and I squared it, if I have a radical that I square, if it's an index of 2, what do I result as for a simplification of that? I'd have the square root of x times the square root of x, which is actually the square root of x squared, isn't it? Which is just then an x. So anytime that I square, if the index is 2, a radical, what is ever inside that radical is the result of squaring or getting rid of the radical. So like here, if I had the square root of 2 squared, isn't that the same as the square root of 2 times the square root of 2? Which is actually the square root of 4. And what's the square root of 4? 2. So if I have an index of 2 and I square that radical, I end up with what was inside the radical without a radical. Okay? So keeping that in mind, as I do a square of the square root of 2x plus 1, what will I get? 2x plus 1 without the radical. And what's 0 squared? 0. Can I solve this for x now? Take 1 to the other side by subtraction.
And then divide by 2 and get x equals -1/2.
Okay. Third step. I need to check for extraneous roots. Or, for those of you who don't like the word root, solutions or answers. Extraneous means something that doesn't work. So when I get down to here where I have x equals a negative 1/2, what I need to do is take that particular value, put it back into the original problem. So the fourth step is basically check your answer by putting the answer that you have back into the original problem and see if it makes sense. So we had that x was equal to a negative 1/2, correct? So put it back in, which means that I have 2 times a negative 1/2 plus 1 equals 0. Well, what's 2 times a negative 1/2? It's a negative 1 plus 1 equals 0. What's a negative 1 plus 1?
0.
What's the square root of 0?
0.
So does 0 equal 0? So back on this side, if it's not erased by now, I just got done checking it. This answer of x equals a negative 1/2 is correct.
Go back down to the first step.
Third step was check for extraneous roots, solutions or answers. In other words, you take the answer that you have and substitute it back into the original. You have to do that. You just have to do it. Okay?
How can you tell if it's different though, if you're just putting it in and it doesn't matter?
If you put it in, okay, like I did over here, right? If I put it in and I don't get these two equal to each other, then it's...
3 and 4 are basically the same thing.
Yes. If I don't get them equal to each other, then the answer that you got, it doesn't work. Okay? Extraneous, that's what it's called. Means roots that don't work. Okay? So let's take this problem. X minus 5 equals a negative 4. Square root of x minus 5 equals a negative 4. What was the first step?
Have to take the root or take the radical by itself.
Get the radical by itself or isolate it by itself, right? Okay, if I look at this particular problem, is the radical by itself? Okay, so if the radical is by itself, what was the second step that we do? Okay, look at the index, and in this case it's a 2, isn't it? Because there's nothing mentioned there. So I need to square both sides. So x minus 5 in the radical squared equals a negative 4 squared. X minus 5 equals positive or negative?
Positive.
Okay, so a negative 4 times a negative 4 is 16, correct? Okay?
Then you solve it. You take x, or if you add 5 to it, x equals 21.
So I got an answer of 21 right now, don't I? Okay, so then I have to check, which means take the original problem, put in your answer, What's 21 minus 5? What's the square root of 16?
4.
Does 4 equal a negative 4? So, actually, the x equals 21 is an extraneous root then. Okay? So I end up with no solution. Because when I went back to check, the 4 or the 21, when I put it back in, did not give me something that equaled on both sides, right? So it doesn't work. So in this case, I have an extraneous root of 21. Why do I end up with an extraneous root? It is because when I square things, they always become positive, don't they? So this actually became a positive number, which really throws off answers. Okay?
So do we have to state that as an extraneous?
When you do the checking, if it doesn't work, then you say no solution.
I didn't know if I could ask you to say, explain or something.
Yeah, that's what you're doing. When they say check for extraneous roots, that's what I did. Okay. So let's do the following problem. X minus 4 plus 6 equals 10. Your first step, okay? So isolate the radical by itself. So 10 minus 6 is 4, isn't it?
And then square everything to the next 2.
Okay, since the index is 2, I need to square both sides.
So you get x minus 4. And then you gotta solve it to the x equals 10. You substitute 21 for the original.
Okay, so take the original problem, which was x minus 4 plus 6 equals 10. Put the 20 in for the x.
You get 16, or 16 is 4 plus 6.
Okay. So you said the square root of 16 is 4 plus 6 equals 10. Does 10 equal 10?
Yeah.
So was the x equals 20 a root?
Yes.
So that is my answer. Okay?